Good day viewers, you all welcome back to this channel. Okay, this is another fresh edition on standard derivative. This is episode 3. Okay, and in today's video I'll be looking at the last concept which I promised you guys to finish. Look at the derivative of y equals to sin x, and that's what. Okay, said if you look for the derivative of y equals to sin x, that will give us cos x. Or if you look at the derivative of y equals to cos x, we are going to have a negative sin x. Okay, and the third one, we're going to look at the derivative of y equals to the exponential function of x, that is ex, e to the power of x. What are we going to have for that? Okay, don't forget, this is Mathematics Clinic by Tutor Chris. Kindly subscribe to my channel, and if you find any of my videos interesting, kindly share them with your colleagues and tell them to subscribe to this channel, turn on the notification, so whenever I upload a video you will also be able to watch. Okay, and I promise you guys will never regret joining this channel. Alright, let's move on to today's course now. Having y equals to e of x, the first thing I would like to let you know is that e of x, this e of x, the exponent over x is given as 1 plus x is a series, is given as a series 1 plus x plus s squared over 2 factorial plus x cubed over 3 factorial plus x to the power 4 over 4 factorial plus dot. This is telling us that the 3 dots here is telling us that the series continues. I hope you guys know the difference between the series and the sequence. When we are talking about series, there is the addition of terms. You can see we are adding the terms together. Okay, but the sequence is not like this. Okay, when we are talking about series, it's the addition of terms. Okay, alright, now let's move on. If our e of x is given to be this, now if we differentiate all this function, that is 1 x to the power of 2, x to the power of 3, x to the power of 4, we differentiate them with respect to x. Okay, that is this one I'm talking about, the y, the x. Differentiate them with respect to x. Now no, it is differentiating constant with respect to x, that's gonna give us 0, and if we differentiate x with respect to x, we are going to have 1. Okay, and if we differentiate x squared with respect to x, that is 2x over 2 factorial. Okay, plus differentiating this with respect to x, that's x to the power of 3 to the power of 3x to the power of 2, okay, over 3 factorial, plus now this is 4x to the power of 3 over 4 factorial plus dot. Okay, this is wonderful. Okay, now let's continue. This implies that our dy dx will be giving us, this is 0 plus 1. Okay, let me say this 1. No, 0 plus 1 is going to give us 1, and then 2x, 2 factorial is 2 multiplied by 1. That means that 2 will cancel 2, so I'm going to have, or let me show you. Okay, don't forget, this is 2x over 2 times 1, that's 2 factorial, plus of course 3x squared over 2 factorial, that's 3 multiplied by 2 multiplied by 1. Okay, plus 4x to the power of 3 over 4 factorial, 4 multiplied by 3 multiplied by 2. This is variable. Okay, now this now implies, of course, that I'm having 1. 2 will cancel 2. Don't forget, 2 multiplied by 1 is 2, so I'm having 1 plus x. Okay, this is 3. Now 3 will cancel 3. Okay, so I'm going to be left with x squared over this will be 1 multiplied by 2 now, x squared over 2. Okay, plus 4 will cancel 4 here, so I will be left with x to the power of 3. Okay, x to the power of 3, and 3 multiplied by 2, that's 6. I'm having this. Alright, this is my dy dx. Okay, so now what I'm trying to say is that the derivative of e of x, that is the exponential function of x, is equals to is equals to the exponential function of x, that is the x over e to the power of x is equals to e to the power of x. If we differentiate this with respect to x, we are going to have this again. Okay, so that shows us that the derivative of the exponential function of x is same to the exponential function of x. Why? Look at what we're having here, which is 1 plus 2 plus x squared over 2 plus x to the power of 3 over 6. And if we look at this now, this is same thing as I'm talking about this. So let me make use of this arrow to show you. So this is 1 plus, don't forget this, x to the power of 2, and then 2 can also be written as 2 factorial. You know that's 2 multiplied by 1, which is same thing as 2, plus this is x to the power of 3, okay, over this is something as 3 factorial, that's 3 multiplied by 2 multiplied by 1, which is 6. Okay, you can see same thing as what we're having here. Okay, this is 1 plus x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial. Okay, that shows that oh my god, I made a mistake here. My god, let me clear this. Okay, I'm so sorry. I will have to clean this, don't forget. I'm so sorry for that. All right, this is what I'm talking about now. Now if we differentiate this, well, now after differentiating this, we are going to have this will be 1 plus, you know, 2 I've cancelled 2, I'm left with x over 1. I forgot to write that. Okay, that's x plus, if we cancel this now, I'm going to have the value of this is x to the power of 2 over 2, x to the power of 2 over 2. Okay, and this will cancel this. I'm going to have a plus x to the power of 3 over 6. Okay, plus dot dot dot. Okay, now I will have to clean what I just wrote here now. Okay, there's a little mistake there, I'm so sorry for that. No, okay, now this means that I said if we differentiate a to the power of x, that is the exponential function of x, I'm still going to have the exponential function of x. Now look at what we're having here. I want to show you the differentiation, that is the change in the exponential function of x with respect to x is the same thing as this. No, after differentiating this function here, this is what we are having here. Okay, so that shows that I'm having 1 plus x, and then x to the power of 2 can also be rewritten as x to the power of 2 over 2 factorial. You know that's 2 multiplied by 1, which is same thing as 2, plus now x to the power of 3 over 6. This can be rewritten as 3 factorial. You know 3 multiplied by 2 multiplied by 1, that's same thing as 6, plus dot dot dot. Look at it. Is it not what we are having here? You know, e of x, that is the exponential function of x, equals to 1 plus x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial. Now look at this. Now I'm having 1, which is 1 here. I'm having x to the power of 2 over 2 factorial x to the power of 3 over 3 factorial. So therefore, if we differentiate, that is the derivative of exponential function of x here will give us the exponential function of x. Well, that's clear. Okay, and don't forget, I make use of you know, if you're having what is it called, that is this is what I'm talking about now. You're having x to the power of n. If you want to differentiate this is something as n into x to the power of n minus 1. That is, the power will come here and we are going to subtract 1 from the power. That's what we mean by derivative. Okay, all right, I hope you enjoyed this video, and if you like this kind of video, don't hesitate to subscribe to this channel. Tell your friends about this channel. Okay, in my next video we'll be looking at another beautiful concept which I know you won't be ready to lose. Okay, you won't be ready to miss. Okay, so keep your seatbelt tight and let's continue to drive. Okay, thank you, see you next time.